Hi, thanks for joining me for a discussion on pavement preservation. I thought before I got into talking about the actual pavement preservation tools, techniques, maybe we would talk a little bit about the scope and scale of the issue. So if we look at a rough estimate of roads in the US, we've got about 4 million miles of roads. It's a lot of miles. And when we look at who owns roads in the US, about a little less than 25% of those roads are owned by state or federal institutions. So if we just do some quick math, say about $3.3 million per mile of state road or a federal road, that gives us about $3.1 trillion in asset value. That's a huge number. When we start looking at local roads, the number is really just about the same. So about 77% of all miles of public road are owned by local agencies. So even though they may cost less, if we just take a back of the envelope number of about $1 million per mile, we still have about $3.5 trillion worth of asset value. So again, these are on the same order of magnitude. This is a massive, massive, massive number. And this huge investment are what local agencies are managing every year. We start talking about asset management, start talking about preventive maintenance, we first have to talk about windows of opportunity and costs and cost effectiveness. So with every pavement treatment, there's a window of opportunity where we can do a fix and get a benefit. And if we're outside that window of opportunity, it's less likely we're going to get that fix. So take, for example, changing the oil in your car. It has a window of opportunity of somewhere between 3,000 to 5,000 miles, right? If I go out and I change my oil every 500 miles, it really doesn't do me any good. I'm just wasting money. If I wait, say, for 50,000 miles and change my oil, I've already done damage. So preventive maintenance treatments are no different when we start talking about that with pavements. There's a window of opportunity where we can apply a fix and get a benefit. And if we look kind of at the classic S-shaped curve for deterioration, if we're going from, say, a good quality asset to a poor or failed asset, we pass through each one of these different windows of opportunity. Now, an ideal approach is to try to hit every one of these windows of opportunity where we can do a treatment, because as we get lower in these different windows, we go from preventive maintenance, like say a crack seal or a fog seal, which really doesn't cost us a lot, to heavier maintenance like bituminous surface treatments, like chip seals, slurry seals, microsurfaces, down to rehabilitations like crush and shape, and finally to reconstruction. And as everybody knows, when we get down to these heavier treatments, reconstructions, crush and shapes, they cost a lot more. So the project dollars are larger, right? The project volumes are larger. So we can do fewer and fewer miles of road. But what a lot of people miss is that the cost effectiveness changes. So as we get farther down in the scale, we get towards rehabilitation, asset replacement, the cost effectiveness, so what our dollar buys us in terms of life, reduces. It gets smaller and smaller. So we're really fighting two things. We're fighting larger project costs, which allow us to do less miles, and less cost effectiveness, which costs us to spend more money to gain a year of life. And that's really the principle behind preventive maintenance. Just taking a look at some back of the envelope numbers. Again, don't get too hung up on the numbers, but if we look at these basic fixes like crack seal, might cost us somewhere between $2,000 to $4,000 or $5,000 per mile. We get, generally speaking, 1 to 2 years of service life out of those fixes. Divide our cost per lane mile by what we think we're going to get on average, and we get a cost per year of added life somewhere around that $2,000 to $3,000 per year of life. As we go down into bituminous surface treatments like chip seals, cape seals, we're still in that same order of magnitude, $2,000 to $3,000 per year of service life. As we start getting into these heavier fixes, if we go from, say, a cape seal to an overlay, our dollar volume increases, as we've seen, but our years of added life don't double, right? So even though our costs have more than doubled, our year of service life really haven't doubled. So our cost effectiveness, what we pay to get a year of service life, is basically twice what we paid in the previous class of treatments. And when we go down to reconstruction, that we lose efficiency again. It's going to cost us more money to gain a year of treatment life. So ideally, you're collecting data on all of these these different treatments on your own. The costs, I'm sure everybody's pretty cognizant of the different costs that are out there, but also the service lives that you're actually getting out in the field through doing different treatment life studies. Now, if you haven't, you can certainly use different studies. Here's a report that we did for our Michigan Transportation Asset Management Council. It was looking at the extended service lives of different types of treatments from local agencies' data. So they sent us their data and we analyzed the data and came up with the actual in-service treatment lives. So again, there's other published information on that. We also have a treatment cost report. Again, Michigan Transportation Asset Management asked us to look at the costs of all projects in 2016 and 2017 to come up with the costs per lane mile for these different costs. So again, these are places to start if you don't have your own data, but ideally you're collecting this data on your own so you can look at the cost efficiency of these different treatments in service on your network. Okay, so that's the basics. Now let's talk about what kills pavements. Before we get into fixes, we have to know what we're trying to do. So there's three basic killers for pavements, and that doesn't matter if we're talking about concrete pavements or asphalt pavements. There's three killers, and we can use preventive maintenance to offset damage caused by two of them. So the first one we want to talk about is traffic. So as we have traffic use the pavement actually flexes if it's an asphalt pavement. So we'll talk primarily about asphalt pavements here. So before a vehicle comes, the pavement will actually rise up. It'll actually bow up, and then it'll go back to a neutral position, and then it'll actually flex down. So there's actually a pressure wave that travels through the pavement as a vehicle travels down the pavement. Actually, there's a kind of a neat video. This one is a little bit old. It's I think it's from the maybe 80s. So this is showing a position gauge that's showing that pressure wave coming. You can actually see the pavement has risen up, and then now it deflects down as the tire goes past it. So we can see that flexing of the pavement, that pressure wave that travels. And so every time we flex our pavement, we're actually taking life out of the pavement. An asphalt pavement actually has almost, you can think about it like an odometer. It's got a design value in it that has a certain number of repetitive loads that it can withstand before we start to see failures like this, like reflective cracking or fatigue cracking rather. So we can get this type of failure if we're using really heavy loads, and heavy is a relative term, heavier than the pavement was designed to carry, or just over a long period of time, we get these types of failures just as we run through enough cycles of flexing that pavement. The other type of failure we can get from traffic are shear cracks, which are shear cracks in the wheel path. That's where the tire loads are heavy enough to actually cut the pavement or shear the pavement. Now, both of these types of failures that are related to traffic, we can't really do anything with preventive maintenance. Preventive maintenance is not going to fix these. It's not going to actually even slow them down. So the fixes we want to focus on are the next two killers of pavements, which are the environment and moisture. So when we take a new asphalt pavement, and let's just assume we don't even have a vehicle on this pavement, we're never going to touch this road with a car ever, or a truck. When the pavement is brand new, it's hot, right? It's placed hot. It's in the summertime usually, the temperature's up, it's at its maximum volume. But if we think about it, an asphalt road, an asphalt surface of the road is actually a really long, thin ribbon of material. Very thin, it's only a couple inches. It's only 28 feet, maybe 30 feet wide, and it's several miles long. So it's very long and thin. When it cools, that pavement tries to shrink, but obviously it can't, right? It can't pull its ends together. So what we do is it develops tensile strength inside the asphalt pavement. So it's literally trying to pull itself apart. And when asphalt pavement is new, it is viscoelastic. So it flexes and flows. So with an asphalt pavement surface, that's properly designed, properly built, it can make those transitions between heating and cooling without cracking. Now, over time, if we don't have any sealant on the pavement, we'll see our brand new dark colored asphalt kind of turn to that kind of ash gray color. And that's indicative of our asphalt binder starting to age. So exposure to air, exposure to sun, exposure to water starts to change that asphalt binder, the glue that holds the aggregates together, and it makes it brittle. So over time, as that brittling process, the pavement gets more brittle, that process continues. Eventually, we reach a point where the cold weather will actually snap the pavement, make a break, okay, in the pavement. Usually that's called a transverse crack. And as the pavement ages, we're going to continue getting those kinds of distresses that are just simply a result of the pavement heating and cooling, expanding and contracting, even if you don't put traffic on it. So environment is a killer of pavement. Ideally, we could seal our pavements where we couldn't get oxygen or sun or water into the surface of that pavement. And if you think pavements don't move, we can just look at some of the examples that we've had in the news about concrete pavements, rigid pavements. There's lots of examples where we have miles of concrete that heat up. We get higher temperatures than they're used to. The concrete expands and actually will push up and tent up like this. It's pretty dramatic when it happens. So the same thing is going on with asphalt pavements. They're expanding, but they typically don't tent up like that because they are viscoelastic. So let's talk about our last distress. Our last one is kind of the silent killer. It's moisture, and it's moisture in the pavement. So when we have our first distress, first thing it does is allow water to get down into the pavement layers. And again, the pavement is all of these layers. It's not just the asphalt on the surface. It's the gravel, it's the sand subbase if you have it, and the native material that's below that. So that all goes to building structure in the pavement. We get water in the pavement, it makes those lower layers of the pavement that we depend on for structure more reactive, they're less rigid. So when we run a load over this pavement, the area that's saturated with water is actually not as rigid as the rest of the pavement. So now we've got a break in the pavement, we get moisture in the pavement, we run a load over the pavement, and because the pavement can flex more around that joint, we'll actually start to get another crack. And that crack leads to more water, which leads to more cracks. So we get propagation of distresses. This is kind of a neat photo that shows an original transverse crack that runs kind of right down the center of the pavement, right down the center of the picture. You can see that one side of it was sealed, and that, for the most part, stopped the distress propagation. And if you look on the close side in the photo, you can see that where that original transverse crack is, it's actually, we've got tertiary cracking going on, and the pavement is actually beat down. It's started to go out of its original plane. So this is a serious issue. It's went from something that we could just seal to something now that's structural in nature that we'd have to replace or do a very significant repair on. In addition to kind of the summertime problems that we also have, of course, winter problems. This where we can get de-icers down and moistures down in the pavement once we have a crack. Those pavements can swell, and now all of a sudden we have a bump that we're hitting with traffic, causing impact loading. So again, to a quick video, this is a neat study that was done by NDDOT a while back. They actually built the new pavement and then flooded the area around the pavement. You can actually see the pavement bouncing as trucks go over it. So obviously not a good thing, right? So this is the power of water. So as the load goes over there, we talked about those pressure waves that normally occur in a pavement. Well, when it's saturated, we actually add hydraulic pressure to that. So we can actually magnify that flexing that we get in the pavement. And as you can see, we can quickly fail an asphalt road when we have a saturated base like that. We don't have the support that we have, and then we have that extra flexing from the hydraulic pressure. Okay, so those are the things that are going to kill a pavement, right? Traffic, which we can only deal with structure. The environment, which we try to do by sealing the pavement. And then water, which we try to do by plugging up all the holes in the pavement, sealing the holes in the pavement. So let's talk about a couple of different treatments that are out there. So the old standby crack seal is still a relevant treatment today. So this is Overband crack sealing, and it's pretty straightforward, right? If you had a hole in the roof of your house, you would plug that hole before it did more damage. And that's the same thing with Overband crack sealing or route and fill, which is another method of crack sealing. We're basically using a rubberized asphalt to, first of all, an air lance to clean out the crack. Then we use rubberized asphalt to seal the crack. It's just like tarring the shingles on your roof. It doesn't bond the pavement back together. It's really just a flexible seal that goes in there. And we're trying to create a seal that will flex as that pavement continues to move. So that sealant has to be able to stretch and flex as the pavement gets cold and shrinks again. So again, overband crack sealing, pretty straightforward treatment. Could be as low as $1,500, $1,800 a mile to up to $300,000 or $400,000 or $400 a mile. So we're really just filling the cracks, keeping water and debris out of there. Can last up to 3 years. We typically see somewhere around a year, year and a half of extended service life out of it. And ideally, we're using it for non-working cracks under under 3/4 of an inch wide. So a very early repair that we can do on a pavement. Another treatment that we can do that's a very early preventive maintenance is fog seal. So this is fog seal in its entirety. It's basically cleaning the pavement and then spraying an asphalt emulsion over the surface. And so fog seal is basically going to seal in the asphalt surface. So when we have a good new asphalt surface that doesn't have a lot of cracks, we spray a shot of fog seal, which is an asphalt emulsion, onto the surface. The emulsion breaks, which means the moisture goes off of it, and we're left with the asphalt surfacing material. And it's almost like painting the road. Now, people would say, well, why would you do that? Well, we're trying to seal in that asphalt layer and protect it from the environment. We're trying to protect it from getting brittle before it cracks. So fog seal is a real good early treatment for a good pavement. And the main idea on it is just like painting steel on a bridge. It's trying to retard the oxidization that goes on in our surface layer, our asphalt layer. And the whole idea is we're trying to stop that asphalt layer from becoming hard, from becoming brittle. It can seal minor cracks, hairline cracks that you might not even know that are there. It's typically used for really good pavement. And what we're seeing a lot in Michigan is people using fog seals on top of a chip seal. We'll talk about that in a little bit. But typically only lasts about 2 to 3 years, but it's a pretty inexpensive treatment. Okay, now we're on to a little bit heavier treatments. We're on to a class of treatments called bituminous surface treatments. And these all basically do the same thing. Again, they're not structural in nature. They don't offset damage due to traffic, but they do seal in the pavement. They do keep the moisture out of the pavement. So a chip seal or seal coat, depending on the terminology in your area of the world, it varies where you go. The same treatment is called basically the same thing. Is like a heavy fog seal. You can see in this picture, they've got asphalt emulsion shot down. It's a little heavier this time. And then they've got this chip spreader that's dumping stone chips, a single size stone chip. So a chip seal, like I said, is just like fog seal. We put down an asphalt emulsion layer, thicker this time. And then we go back in with a stone chip and add a veil of stone chips on top of it. We roll it to set the chips. And ideally, we have our stone chips in, say, 60 to 70% of the depth of that asphalt emulsion, so that the chips are sitting outside of that emulsion, but yet they've got good adhesion. We roll it, we sweep it again, and try to get the excess chips off. And that basically makes those chips lay down flat, right? They might not be, we want those chips to fit in their most stable position and lay down. So, chip seal, what we're seeing a lot of here in Michigan is people are coming back with doing a chip seal, rolling it, allowing traffic to set the chips, and then coming back after they sweep and doing a fog seal over the top of the pavement. So this, a lot of people don't know the difference between chip with a fog and new asphalt. So a lot of the public, I should say. So when you're done, you get a really nice surface. It's got that dark, rich black color on the top. You can control the shot rate to make sure that we have enough embedment of our chips. And then we also coat our chips to make sure that the chips are kind of waterproofed. So we're seeing a lot more chip seal and fog seal here in Michigan. And from the studies that we've done on treatment life, it looks, at least in the studies that we've looked at, chip and fog have typically lasted several years more than just a chip alone. Now, we can't say if that's a treatment for sure, or if that's just that the local agencies that we work with, if they're being more careful when they do a chip and fog seal. So, but like I said, most of our local agencies are going to a chip followed by a fog. So biggest issue with chip seals is the extra chips. right? So there's always going to be an extra set of chips or extra quantity of chips that are out there. We want to get those chips off for a couple of reasons. They're a nuisance. Public hates them. They end up in their yards. They break windshields. But more than that, the extra chips actually act like little drill bits, and they actually, as traffic runs down, those chips actually try to force their way in between the other stones that are glued down. So it can actually start to damage your pavement. If we look at chip seals, they're not a structural treatment. None of these bituminous surface treatments that I'm going to talk about are structural, which means that they don't offset damage, structural damage to the pavement. So they don't have rut filling capacity. Generally speaking, they last somewhere between 3 to 7 years. That's the extra service life they get. In Michigan, we're seeing about 5 years on average in service life. And another kind of an interesting thing that we're seeing is local agencies are starting to use these proactively. So not as a preventive maintenance, but proactively with new pavements. So let's think about what an asphalt pavement does. We're asking a lot of it as a material, right? We want it to be rigid and have it resist tire loading, permanent deformation. So it needs to be dimensionally stable, but we also want it to be able to flex. So as it heats and cools, we want that asphalt to be able to expand and contract without cracking. So it needs to be very flexible, but it can't be too flexible. Otherwise, when we put a tire load on it, that tire will actually deform the pavement and cause rutting and other damage to the pavement. So we want it to be flexible, but not too flexible, and we want it to be dimensionally stable. So those are two diametrically opposed properties. With a chip seal on top of a pavement, on a new pavement, what we're seeing with a lot of local agencies here in Michigan in new pavements, they're chip sealing within the first year on top of a new pavement. And what that does is it allows our lower layer of pavement to be flexible and be able to expand and contract. And we can use a very flexible upper layer of chip seal, and that can actually withstand that flexing. So even if our lower layer cracks, if our asphalt layer cracks, the chip seal is not likely to crack because it is that very flexible membrane. So our lower layer is dimensionally stable, and if it does crack, we've got a coating on it. So it's kind of an interesting thing. It's almost like a hybrid pavement that people are starting to do here in Michigan. Let's talk about slurry seals and microsurfaces. Next type of treatment. They're very much in the same vein as a chip seal. The main difference is that they are pre-mixed. So they're contractor mixes, and they're pre-mixed and basically laid out on the road, either in a squeegee or a box. And one of the issues, like I said, with chip seals is the chips, right? The excess chips. With slurry seal and microsurface, they're mixed kind of in stoichiometric ratio, so there's not an excess of material. They're already pre-mixed, they're already pre-coated. It comes out, there's no excess material. So that is a benefit. You pay for the benefit though, right? So they're basically applied the same way. The difference between slurry seal and microsurface really is in the materials. So if we look at a slurry seal, again, it's a premix, which means that the contractor mixes up the right amounts of each of the materials, which are asphalt emulsion, fine aggregates, and then a mineral filler. So we don't have the large stones that we see in a chip seal. It seals the pavement just like a chip seal does. So our main thing we're trying to do is stop water. It's also trying to stop the environment from getting at the pavement. It's not structural, so it doesn't fill ruts. It doesn't add to the structure. And it's an emulsion, so it requires warm temperatures to evolve off the moisture and leave the asphalt. So generally speaking, we see about the same performance as a chip seal, around 3 to 6 or 7 years. When we go to a microsurface, that's basically the same process with a different material. Instead of just a standard asphalt, we've got a polymer modified asphalt. And so what's different about that is we actually have a chemical set going on instead of just an emulsion break. So emulsion break, emulsion is oil droplets suspended by water, held in suspension by a surfactant, which is basically a soap, right? And so as emulsions break, that's the moisture, the water drying, and then that just leaves the asphalt material that's left. With microsurfacing, the polymer modified emulsion actually is a chemical set process. So it's making long chain chemicals, like super glue is a long chain chemical. It's making long chain chemicals that actually make the material rigid, dimensionally stable. So microsurfacing seals pavements just like a chip seal would. It has an extra property though, because of the chemical set, it can actually fill ruts and correct pavement slope. So it's dimensionally stable, but that comes with a negative because it can be brittle. So it's not as flexible as some of the treatments we've talked about for bituminous surface treatments. So generally speaking, it lasts about the same in that 3 to 7 year range, but we get an extra property for the extra cost. But again, one of the concerns we have with microsurfacing is brittleness and reflective cracking. So again, we have to pick the right treatment for the right job. Now I want to talk about overlays really quickly, but overlays are typically where we start to think of structural repairs. But there's a key thing I want to talk about overlays before we go into our next treatment. So a challenge with overlays are pretty straightforward, right? We have an old asphalt pavement, we put a new asphalt pavement over top of it. Maybe we mill it, maybe we don't mill it. The biggest issue with doing overlays is reflective cracking. So if we think about this, we've got an old layer of asphalt that's become brittle, and we've got a new layer of asphalt bonded directly to it. When it gets cold, that lower level of pavement is still going to move the same way it used to move before. It's going to move around this joint where we have a crack. And because we've got an upper layer of asphalt bonded right to that layer, all that stress is concentrated right over that crack. So where a new asphalt pavement can actually stretch over a longer area, we've got it constrained to stretch right over that crack. So typically we're going to see reflective cracking on thin asphalt overlays within probably the first year. Sometimes I've seen them even in October, November if it's cold. So reflective cracking leads to lower lives on treatments. So one of the treatments that people are starting to use, or actually they've been used experimentally, but we're seeing a lot more of them here in our area of the world, are what's called a Texas Underseal. So Texas Underseal is basically a chip seal that's applied to a pavement prior to overlaying. There's all sorts of different variations of this. There's variations with fiber, there's variations with different types of geotextiles, but just a straightforward chip seal is something that a lot of our local agencies are using. And then they're paving over top of that chip seal. So what that does is create a stress relief layer. It creates a flexible layer between those two layers of asphalt pavement that allow them to move a little bit differently. Okay, they can move differentially. And that expands the area that stress concentration has to work on it. So it slows reflective cracking or stops reflective cracking. So stress absorbing inner layers are something that DOTs have been experimenting with for a long time. And we're seeing it now with local agencies just being able to apply a chip seal to their pavements before they do overlays. It's really kind of a neat addition to get a long life overlay. Okay, so when we talk about that same concept is a concept that we use for Cape Seal. So Cape Seal is just a chip seal with a microsurface on top of it. So we're trying to get the best of both worlds. We're trying to get the flexibility of the chip seal as an underlayment, and then we're trying to get the more dimensionally stable, better riding surface of the microsurface. So really that's what a Cape Seal looks like in section. We've got the old pavement, we've got a chip on top of it, and then we put a microsurface on top of it. So basically a Cape Seal is like a thin overlay with a stress absorbing inner layer. That's the concept behind a Cape Seal. So it costs a little bit more because we're actually putting two bituminous surface treatments, but the idea is that it's not as much as an overlay. So again, we hope to get 6 to 8 years out of Cape Seals. Again, if they're applied right to the right pavement, and we get that superior surface that we get out of a microsurfacing, where we can correct crown or slope, minor slope issues or rutting. And we also get that lower layer of chip seal that's flexible. Even if the microsurface does crack, we've got that lower layer that can resist cracking and resist moisture intrusion. So Cape Seal is one of those treatments that's been around for a while. People are starting to use them. Okay, so there are a ton of different treatments that are out there. I think that's one of the neat things about preventive maintenance is people are innovating all the time. Big question for somebody that's a practitioner is how do I use it? What are the best applications? What have other people done? And that's again where LTAP centers can help you understand what's worked, what hasn't worked. This is a new resource that's out as of 2020, I think in February. Minnesota's Local Roads Research Board came out with the Minnesota Preventive Maintenance Manual. It's a great manual. It talks about all sorts of different treatments, including some that aren't thoroughly tested yet. They're still being used, where they don't have performance data on it. Talks about when you apply the fix, gives some examples of what the fix looks like. It's a great resource to look at. So closing thoughts, preventive maintenance pays. Clearly it pays. It gives a higher service level because we're touching our pavement more often than if we just construct a pavement, don't touch it for 20 years, and then come back and reconstruct the pavement. If we're touching that pavement in every one of those windows of opportunity, we're getting the lowest cost per year of life we possibly can. So we're giving a better quality road, and we're also getting lower costs. If you're not really using preventive maintenance tools, don't get overwhelmed. When you first look at a manual and you see that there's all these different types of treatments and, I want to pick the best one and I want to make sure I have it right, don't get overwhelmed. Start simple, understand the tools that you have in your area. I live in the extreme northern part of Michigan, so we don't necessarily have contractors that can provide all of those different fixes, those bituminous surface treatments that I talked about today. So chip seal is the most practical because that's the lowest cost in our area, and it's what contractors and what road owners can do in this area. So start simple, start with a couple of tools, and then expand as you start to get different applications. Ideally, when you're doing this, you're also collecting your own data. Keep a file on the costs, keep a file on, if you're rating your pavements, keep a file on that so you can understand what type of service life you're getting out of. And look to proactive types of treatments that are out there. So always ask yourself, when you've done a treatment, why am I doing it? Is it preventive maintenance? Is it trying to be proactive with a hybrid pavement on a new construction, like chip sealing a brand new pavement? Or are we doing something reactive, which might be just as a Band-Aid? Those are three different classes of treatments that we might do. Always think about what we're trying to do. So there's always information coming out with these different types of treatments, and your LTAP center is definitely your place to get the newest information that's out there. Thanks for joining me today for this presentation. If you do have questions, there's my email, and enjoy the rest of the conference. Thank you.